If the creatures fossilized in the rocks show no evolutionary sequence, could they have all lived together at the same time? Since we now know that rocks don't need time to form, just enough sediment, there appears to be some reason to believe that they could have all been living together. What we see is an immense graveyard encircling the Earth of hundreds of millions of fossilized creatures who could have all been victims of the same catastrophe. The very fact that their remains were buried in vast quantities of sediment which has become rock, and that this kind of rock is only made by water, strongly indicates that the catastrophe was a cataclysmic flood that covered the entire Earth.
How old is the Earth? Is it millions of years or just a few thousand years? And what does radiometric dating tell us about the age of rocks? The science of physical chemistry can throw some light on these questions. And Professor Edward Boudreau is a physical, inorganic chemist who teaches at a university in New Orleans, Louisiana, and he has studied these matters. So he should be able to help us. Professor Boudreau, it is explained elsewhere in the program that the strata and the fossils in the rock can give no indication as to the age of those rocks. Can you tell us if there are any other methods by which the rocks of the strata can be dated? For example, by carbon-14 dating.
Well, let us get one thing clear about carbon-14. It is an unstable radioactive form of the element carbon, which occurs in all living matter. A living organism, when it's alive, is absorbing and expelling carbon, a small amount of which is carbon-14. And at some point in time when an organism dies, the carbon-14 that was present, remaining at the point of death, is what would be detected radioactively. A piece of wood, for example, or a bone, would contain a small amount of carbon-14. When the tree which bore the wood, or the animal which bore the bone, died, that carbon-14 that remained is decaying. It takes thousands of years for the decay process to occur. About 5,760 years for half an original amount of carbon-14 to decay into a stable isotope of carbon-12. So by measuring how much of it has decayed, an indication of how long ago the organism was alive can be obtained. As rocks were never alive, they contain no carbon-14. Even the fossils in the rocks cannot be dated by this method because the original living matter in them has turned into stone.
Does this mean that the fossils can't be dated by radioisotopes?
Well, certainly not by carbon-14 with any degree of reliability. As you know, virtually all the fossils are found in sedimentary rocks, and because this type of rock rarely contains radioactive elements, the fossils have had to be dated by rock strata in which they are found. And as we know, the latest experiments show that rock strata give no indication of age. Other types of rocks, such as crystalline rocks, which do not contain fossils, and lava, do sometimes contain radioactive elements, and these isotopes are used to date them.
Can you tell us, in simple terms, how you date a fossil or rock with a radioisotope?
Yes. Let us take a radioactive element such as uranium. This element decays very slowly into a non-radioactive element, which is lead. Now, the rate of the decay can be measured in the laboratory. So by comparing what's left of the uranium element in the rock with the amount of decayed lead element that was formed, and knowing the rate of decay, an idea can be had of how long it has taken for the lead to form.
So if half of the uranium has decayed into lead, and by knowing how long it takes for uranium to decay into lead,
yes,
you can tell the age of the rock.
That's the theory.
Why do you say theory? Surely if it's a process you can observe and measure, it must be a fact.
Not at all. Look again at the diagram. you can see that there are a number of uranium particles, the orange ones, and a number of lead particles, the blue ones. Here we have to make three major assumptions. The first is that all of the lead particles were originally uranium particles, but there is no reason to believe that there were not some lead particles in the rock when it was formed. You see, there is plenty of natural lead in rocks that doesn't come from uranium at all.
Really?
Yes. Let us take the extreme case. If this rock contained radioactive uranium and no lead, then the lead that would appear as a consequence of uranium decay would be a fairly accurate measurement of the age of that rock. Or to take a more likely situation, that at least some of the lead was in the rock when it was formed, then the age of the rock is much less than we are led to believe. Then there's the matter of leaking out due to solubility.
Could that happen?
Most definitely. Salts of uranium and other radioactive elements are quite capable of dissolving in water and therefore will be removed from the sample. So if the rock had been exposed to water for some period of time, such as during a flood, some of the uranium could have been washed out. This would mean that the age ascribed to the rock would be much too great.
But surely there must be other radioactive material and elements which are more reliable than uranium.
Well, there's radioactive thorium, and there is strontium and rubidium, and there's potassium. But these are no more reliable than uranium. The salts of these latter elements are even more soluble in water than uranium salts.
So a worldwide flood would have made all these methods useless.
Most definitely. Let me give you an example of how water can affect radioactive dating. Less than 200 years ago, the Hawaiian volcano Kilauea erupted, and the lava which emerged from that eruption was submerged in water. It was subsequently dated by the potassium-argon method. Clearly, it should have shown the age of the lava to be about 200 years. The date recorded, however, was 22 million years. Obviously, the highly soluble potassium salt had leaked out of the sample and left it looking very old. Other samples taken from Haulula'i volcano lava from 1801 were dated between 160 million and 3,000 million years old.
The situation gets worse and worse.
But there's also another assumption in radiometric dating, and that is that the rate of decay has remained constant and has not been influenced in the past. There are a number of things which could have influenced rates of decay.
Such as?
Well, the production of neutrinos from cosmic radiation could have been enhanced by a reversal of the Earth's magnetic field or the explosion of a supernova in a nearby star. Science has proclaimed that these events have occurred in the past, and they could have a substantial effect, therefore, on the radioactive decay rate.
So, if radiometric dating is no guide, what other methods are available?
There are a great many natural processes which date the Earth to be relatively young. For example, if the compelling evidence that the Earth's magnetic field has been decreasing with time is a fact, then we would find that the Earth would be rather young rather than old.